So we are going to start our next lecture, which is on flags. Again, here is our list of all the registers once again. So as you can see, we have talked about the accumulators. We probably worked with the index register, stack pointers, and program counters. Today we'll look at the very last register we have here on this list, which is called condition code register, in short CCR. Okay. Now, if you look at the CCR, CCR is a one byte register. So here are all the bits we have on the CCR. So this register is a little bit different than the other ones because this register work as flags. Basically, all the 8-bit, each of the bit works as an independent flag bits. So why do you need flags, and what is the meaning of flag? The flags are something which are controlled by the microprocessor. So basically, let's say you are doing an operation, addition, subtraction, or something else. Now, for some reason, your operation has a wrong answer. It's possible, right? Because a lot of times you have seen that your microprocessor cannot accommodate the result in the indicated register or indicated memory location, or something happens. So think about how microprocessor will notify you that something happened. Because microprocessor a lot of times cannot fix the problem, but can notify that something happened. Okay. Now flag is something which is controlled by the microprocessor, and through the flags, microprocessor can tell you that let's say your operation is not right. Okay. Now that means this is a register which is controlled by the microprocessor. Okay. You can still work with the register, but we will have these 8 bits which are called condition bits. That's how this register becomes condition code register. Okay. Now, what actually these condition bits are the ones which actually stores the current value of different conditions. We'll talk about this detail. And condition bits, as you can guess, these are bits, so it can always change between 0 and 1, right? Now, if it is 0, any of the bit is 0, that means the bit is clear. Or if the bit is set, that means the bit is high. So we always call, oh, condition is set or condition is clear. Okay. Condition bits changes due to the instructions. So, and how this changes, we'll talk about this in this lecture. So again, here are our 8 condition bits, but in this lecture we'll actually talk about the last 4 condition bits. Okay. Meaning N, Z, V, and C flags. So again, in this lecture, we'll only cover the last 4 bits, which are the last 4 flags of the condition code register. N flag, Z flag, V flag, and C flag. Each of these are called flag. Okay. Now we'll start with the very rightmost one, which is the C flag, which is also called carry or borrow flag. Okay. Now, what is the purpose of this register? What is the purpose of this flag? Now, this flag is set. Again, set means what? High, right? This flag is set high when an addition produces a carry of 1 at the end. For an example, let's say your microprocessor is adding 83 and 9A. When you add it, look at the answer. Look at the sum. You have a carry at the very end. Look at the red circle carry, which is you have at the very end. So remember, in additions, you may have carry, you may not have carry at the end. Now, if you have a carry at the end, the C flag is automatically set. So this is a way the microprocessor will let you know, oh, okay, something happened, there is a carry set, okay? Now, if you really want to know whether the carry is set or not, you can always double check the carry flags, or your other instructions can read the flag. Now, meaning your microprocessor can read the flag. Now, this also tells, a lot of times you have seen that, let's say you are trying to save the result in accumulator A or accumulator B, so you will actually not be able to save this carry, because the accumulator A and accumulator B are 1 byte long. So you'll be able to save like 1D, and this one is actually dropped. The carry, the one carry is dropped. Now, here, if you look at carefully, even if it is dropped, microprocessor is actually letting you know, oh, okay, you had a carry. Okay. Now, in case of subtraction, you get a carry when you have to borrow from outside. For an example, let's say if you are doing this subtraction, you are subtracting 9A from 83. What happens? You see here at the very end, you actually have to borrow 1 from outside, because 83 is actually a lower number than 9A, right? So you have to borrow a 1 at the very end from outside. This is how we actually do the subtraction when the top number, meaning the first number, is lower than the second number. Okay. Now remember, the first number is called minuend, and second number is called subtrahend. Meaning, whenever the minuend is lower than subtrahend, then we actually borrow a 1 from outside. So at that point, your result becomes negative. How do I know the result is negative? Remember the 2's complement? Whenever you have a 1 in binary at the very left side, the result is negative. That means whenever the leftmost digit of this hex number is 8 or more, because 8 is the first digit which actually starts with a 1 in binary, right? Think about 8. What is 8 in binary? 1, 0, 0, 0, right? That is 8. So that is the first number, meaning that is the first hex digit which actually shows a negative number if 8 is at the left side. Okay. So again, if, to make it simple, if the minuend, meaning the first number, is lower than the second number, and you are doing a subtraction, this will always occur. Okay, meaning you have to borrow. So these are the two conditions when the C flag is set. Let's look at N flag. We'll cover all these flags, but we're just doing a little bit in different order. So the N flags is also called sign flag. That means it actually depends on the sign of the number. Meaning, if the number is negative, N flag becomes set. Okay, N flag is set. So how do I know whether the number is negative? Just we mentioned that N flag depends on the most significant bit of a number. What is the most significant bit? The very leftmost bit. Okay, so it's set if the result is negative. Meaning, let's say you are doing an addition, let's say you are doing a subtraction, or you are doing something else. If your result of addition and subtraction is negative, then this flag is set. Okay, and again, it is cleared if you get a positive result. Okay, cleared means what? It becomes 0, right? Now, 0 flag. Okay, before I move on, how do I know whether the number is negative? I can always convert the number in binary, one option, and check the very leftmost bit. Okay, that's one easy option. You can always convert any hex number to binary. Even you can use a calculator and then look at the very leftmost bit. You just have like 8 bit, check the very leftmost bit. If you have 16 bit, again you check the very leftmost bit. Another way is, if you are representing the number in hex, just check the very leftmost hex digit. If the leftmost hex digit is 8 or more, then you know that number is negative. Because the 8 is the first hex digit where you need a 1 at the left side, right? Again, what is 8 in binary? 1, 0, 0, 0. So 8 starts with a 1, right? And anything after 8, like 9, A, B, C, D, E, F, all this starts with a 1 at the left side. So basically your hex number, if the hex number starts with 8 or more, that means this is a negative number. Okay? Because the most significant bit actually represents the sign. If the most significant bit is 0, that means you are writing a positive number. If the most significant bit is 1, you are writing a negative number. This is exactly what we did in the digital circuit class when we represent the 2's complement. Remember we did the 2's complement and then we did a sign, meaning we were able to identify whether this is a sign number and find it. Okay, that's exactly what I'm telling right now. Okay, now let's look at the next flag, which is called zero flag. As you can guess, zero flag is set when your result is absolute 0, all 0. Okay, and it gets cleared when result is not 0, something else, maybe positive number, maybe negative number, not 0. As we are talking about only the last 4 flags of the condition code register today, so here is our last flag for today, which is called V flag. Now the V flag is also called overflow flag. So V flag is the 2's complement overflow flag, and we'll try to understand how the V flag works. But before I start with the V flag, remember the V flag always tell you whether the result you got has a wrong sign. This is very interesting because of the way we represent the negative number in the digital calculations, digital math. A lot of times, no matter how hard you try, your result will not be accurate, will not be correct. And your microprocessor cannot fix it, but microprocessor can let you know, oh, the result is not right, through the V flag. That's what I'm saying? Even if the microprocessor cannot fix it, but microprocessor is letting you know, oh, okay, the result is not right. So, and from there, you can always do something else to compensate the error. Okay? But let us first see how the V flag works. This is the most exciting one. Now, here is how the V flag works. Now, V flag, we are showing here the V flag in case of addition and subtraction. Now, if you are doing an addition, look at this slide very carefully. This is important for V flag. If you are doing an addition, if both numbers are positive, okay, but the result is negative, you are doing an addition, okay, the result means what? Sum. So if you are adding two positive numbers and the result is negative, or if you are adding two negative numbers but the result is positive, then V flag set. This might be interesting to you, how the result can be negative when you are adding to positive number, right? Yeah. Or how the result can be positive when you are adding to negative numbers. Just in the traditional math, that's impossible. But in the digital math, that's possible because of the representation of negative number, okay? And we'll show you how it happens. In case of subtraction, this is a little bit more tricky. In case of subtraction, if your minuend is positive and subtrahend is negative, and the difference is also negative, that means in both cases, if you look at carefully, if your numbers have different sign, but the subtrahend and the difference have the same sign. Now what is subtrahend again? Subtrahend is the second number, right? And the difference is the result. That means if you are doing a subtraction where minuend and subtrahend have different sign, but subtrahend and the difference have the same sign, like this one here, see the minuend is positive, subtrahend is negative, and the difference is negative, or this one where the minuend is negative but the subtrahend and the difference are positive. Now in both cases, your V flag is set. Now remember, there may be other cases where V flag will not set. Now these are the 4 cases. In case of addition and subtraction, your V flag will be set. Now you might be wondering what happens if I'm not doing an addition and subtraction, because some of the, all the operations are not addition and subtraction, right? There are plenty of other operations. Now if you're doing something else other than addition and subtraction, then the V flag set by these formula. Now what is this formula? V flag depends on N flag and C flag. That means you actually have to calculate the N flag and C flag first. What is N flag? The negative flag, right? N flag sets when the number is negative, and the C flag sets when you have a carry in case of addition at the end, or when you have to borrow a 1 in case of subtraction from outside. So you do an exclusive OR. You know this operation, right? Let's recall what is exclusive OR. Exclusive OR gives you high when both of the inputs are different, right? Meaning opposite. So basically one of the input is 1 and other one is 0. If both inputs are same, meaning both are 0 or both are 1s, then exclusive OR gives you 0, right? So basically your N flag and C flag will determine what will be the V flag, okay? In case you are not doing a subtraction and or addition. You know what happens in case of subtraction addition, right, from the last slide. Now this formula applies only when you are doing something else other than addition or subtraction, okay? Now still the addition subtraction rule apply from the previous slide. Now here are the interesting term. How do I know that which flags are affected by which instructions? Remember I said at the very beginning that the instructions actually affect these flags. Basically, based on the instruction, flags keep changing. Meaning, based on the last instruction executed, your flag will be changed. Now, we have some interesting question. Now, the first question we have is, does all instructions affect these 4 flags? No. So how do I know then which flags affect which one? Okay, I know it from the last 4 columns of my instruction set. So here are my instruction set. I'm just showing you a snapshot of a very small portion of the instruction set. All I have to do is just look at the very last column. Look at the very last column I squared with a red. I have a red square there, right? Do you see this N, Z, V, and C there? Basically, these are the 4 columns which are telling you what flags are being affected because of the instruction you have at the left side. Now, here we have several different symbols. Now, how do I know which symbol means what? If you have a small triangle there, you see, you can have a small triangle. Now, if you have a small triangle, that means the flag is affected by this instruction. Now, affected means what? The flag can be either set or can be cleared. We don't know it. We have to calculate to understand it. Okay, that means flag is affected. Now, if you see a dash there or a hyphen, then you know that flag is not affected by this instruction. That means no matter what the instruction does, flag will not change. Okay, or if you have a 0 written, that means this flag will be always cleared by the instruction, no matter what is the outcome. No matter what is the outcome. Okay. If there is a 1, as you can guess, the flag is always set by this instruction, no matter what is the outcome of the instruction. You see what I'm saying? So, as you can see, we are showing one of the instruction here, which is AND A. If you look at here, the 4 condition bits, that means the AND flag is affected. That means AND flag can be set or cleared based on the outcome. Z flag can be set or cleared based on the outcome. V flag will be always 0. That means no matter what the V flag was, V flag will be cleared because of the instruction, irrespective of the outcome. And look at the C flag. C flag is not affected by this instruction. That means C flag will remain same. Nothing will change in the C flag because of this instruction. So basically, just looking at the 4 columns, we can tell which flags are affected by this instruction for every instruction we have on the instruction in the instruction set. Any question here? If not, let's look at a couple of quick examples. Let's say here we are doing an addition, just adding 2 numbers. Which flags are set out of these 4? Again, anytime if we mention flags, we're actually talking about those 4 flags. Okay. Now let's look at the sum first. Now if we add 2a plus 2a, we got 54 in hex. So first of all, 54 is not a negative number, right? How can I tell? Because we look at the very left hex digit, right? That is not 8 or higher. That is less than 8. I'm saying you can always convert it to binary and always check, but that's another way, just looking at the hex. So the negative flag will not set, right? So the negative flag is 0, meaning negative flag is cleared. The result is not absolute 0. That means 0 flag is not set either. The result is 54, right? So that's not 0. Now we are doing an addition and there is no carry at the end, right? So that means carry flag is not set either. Okay. How about the V flag? Remember, the V flag set when, in case of addition, V flag set when both of these numbers are positive and the result is negative, which is not the case. Because both of these numbers are positive, right? This is a positive number, this is a positive number, this is also a positive number. So it did not fall to any of the 4 categories we have for addition and subtraction. Okay? So basically, all of the flags are cleared, which is also an answer, meaning you have to tell, right, which flags are set, which are not. Any question here? Let's look at another example. Let's say we are adding 2 numbers, 91 and 91 in hex. Okay? And this is what is the result. Now this time, the result is not negative. Again, the result means 22, okay? Which is not a negative number, so the negative flag is 0. It's cleared. Result is not 0 because 22 is the result. So 0 flag is cleared. The carry flag is set. Why? Because you see there is a carry, right, at the end. Carry will be ignored, but since there is a carry, the carry flag is set. And from the carry flag, you can tell, oh, there was a carry, even if you don't see the carry because the carry was deleted or dropped, right? What happened to the V flag? Let's look at the numbers. See the first number, this is a negative number, right? Second number, negative number. What is the result? 22. Do you see this happens in digital math, that you are adding to negative numbers, but the result is positive? So the V flag is set. Now, through the V flag, your microprocessor is letting you know, oh, you got a wrong sign in the number. That means your result is not right. Microprocessor cannot fix it, but you know the result is wrong. Okay? Any question here? So the V flag is set, right? Question? Let's look at another example. This time we are doing a subtraction. Okay? So we are subtracting 7c from B1. So that means the B1 is negative, right? And the 7c is a positive number. Oh, remember I said if the left digit is 8 or higher.
Oh, okay.
You can convert it to binary and check, because if you convert it to binary, if the very leftmost digit is 0, that's positive. If the very leftmost digit is 1, that is negative, right? And if you know, you can always set it from hex if this is like 8 or more. So the first number is negative, second number is positive, right? If you do the subtraction, you get 35. Now, first of all, negative flag is 0. It's not set. This is not a negative, right? Negative number, right? 35 is positive. So 0 flag is not set either because 35 is not 0. C flag is not set because this was a subtraction and you did not have to borrow anything, right? In case of subtraction, a lot of times you have to borrow from outside when the first number, meaning the mean one, is lower than the second number. V flag is set. Why? Look at the number again. It falls in one of the 2 categories we have for the subtraction. What is the category? This is a negative number. This is a positive number. This is also positive. Remember, one of the category was your minuend and subtrahend have different sign, right? But the subtrahend and the difference has the same sign. Look at the subtrahend. This is positive. Look at the minuend. I'm saying look at the difference. Same sign, right? So basically, if these two has the same sign, but these two has the different sign, in case of subtraction, reflex sets, right? Remember, we have 4 categories, right? You can just match and tell. Any question? Let's look at
It's negative because it's bigger than 8, the
first digit, yeah. So why it is negative? It's not bigger, I would not say bigger than 8, 8 or more. 8 is also negative because the reason is, again, 8 starts with 1, right, in binary.
Okay.
So any hex digit that starts with 1, if that hex digit is at the left side, then you can tell that is a negative number. Any question here? All right. So if not, then we can go to our quiz section and we can try our next quiz, which is quiz 7. Now in this quiz, every question you will be given an addition or a subtraction. Okay? So you have to just do whatever we did here, just looking at the addition and subtraction and from the result, meaning the division, sum or the difference, you have to tell which flags are set. Remember, in some cases, none of the flag will be set, right? So only you have to tell which flags are set. But be careful, in some questions you have multiple answers because you have multiple flags set, right? As you have seen here. So let's go to the quiz section. Let's try this quiz very quickly. We are not done with the flags yet. We'll talk about the flags again later on, okay? But this is the introduction to flags. So we are just doing one quiz this time, but we'll talk about the flags. We will again talk about the flags in many other lectures in future, okay? Because the flags are so important. So let's stop our presentation here.